Okay, these are your notes for May 12th. This will be the last thing that I do. I'm going to do some notes today and tomorrow on a lot of chart probabilities. And then I'm going to give a quiz on Thursday, and then that's really it. So again, email me if you guys are still continuing on, if you need to make up any missed work or anything like that. That's pretty much it. So Thursday is going to be the last day. All right, so you are going to see some charts that look like this, the one that I'm showing you right here. There'll be one on Schoology tonight, and I think it's dealing with people that own certain types of Toyota vehicles and if they're red or blue. They're all basically set up the same. So there's some keywords you're going to see here, and those words are and, or, and given. And for most of these, you can give me your answer as a percent. So again, if you divide two numbers and get whatever 0.268, just tell me that's 26.8%. You're going to see some problems in Schoology, and I just basically took it to the nearest tenth. So you're going to see some problems. So when you do your decimals, just change them to percents real quick. So you'll probably need a calculator for these. I know you will for probably the ones you're going to do for homework classwork. So what this is this chart shows people that own poodles and people that don't own poodles, and then people that own pink cars and people that do not own pink cars. I have no idea who did this survey, but apparently they did. So what you need to do, and you'll have to do the same thing for homework, is you're going to have to make an extra column and put totals. And not only are you going to have totals for poodles and don't own poodles, you're going to have totals for who owns pink cars and who does not own pink cars. So I'm going to do the total poodles. So 1250 and 250, we're at 1500. Do not own poodles 450 and 18,350 is 18,800. Sometimes you're going to get these big numbers. People that own pink cars, that's 250 and 450, so that's 700. And people that do not own pink cars, that's 1250 and 18,350, 19,600. And this is key. Make sure you get an overall total right here, because that's normally going to be your denominator. Not always, but that's normally going to be your denominator when you go to divide. And make sure that the total on the horizontal column or on the vertical column and the horizontal both add up to the same. So if they don't, you know you made a mistake. Okay, so I got 20,300. And I'm going to double check it. 18,800. I got 20,300 both times. Normally this will be your denominator, but not always. Okay, so the first question says, what's the probability that a person selected at random owns a poodle? So what we're going to do is take all the people that own poodles, which the total that own poodles is 1,500, and divide it by the total, which is 20,300. And I'm going to go ahead and change it to a percent. So 1,500 divided by 20,300, 0.0738. I'm going to move it two places, so that's going to be 7.4%. Right there. B, owns a pink car. So I'm going to take all the people that own pink cars. The total was 700. And divide that by 20,300, the total. See what that gives me. 3.4%. Okay, here's the key word on C. Owns a poodle given that they own a pink car. So there's your key word right there, given. Whenever it's given, whatever comes after the word given is your new denominator. So all we care about, We want to know how many people own a poodle given that they own a pink car. So your denominator, if they use given, is how many people own pink cars. Well, I need to look. How many people own pink cars? Should have been 700. That's my new denominator. Now, out of those 700 people, how many own a poodle? So when I'm looking at 700 and how many own a poodle, it was only 250 out of those 700. All right? So if I do 250 divided by 700, 35.7%. So I'm going to put that answer over here. 35.7%. Anytime they use the word given, you're going to see that later. Whatever comes after the word given, that's your new denominator. Okay? All right, let's look at D. Looks like the same type of problem. Owns a pink car, there's that keyword given, that they own a poodle. So if I see the word given, I'm going to take whatever's after that, and that's my new denominator. Given that they own poodles. So I'm only concerned with the people that own poodles. And when I look here on owning poodles, there's 1,500 people. So I'm going to put 1,500 as my denominator. Now out of those 1,500, I'm concerned with who owns a pink car. So if they own a poodle, how many of them have a pink car? Okay, so owns a pink car, given that they own a poodle. So if they own a pink car, that's 250. All right, so 250 divided by 1,500, 16.66%. So I'm going to bump it up, 16.7%. All right. All right, let's go to E. Owns a poodle and owns a pink car. If you see the word and, it's where the row and column meet. Owns a poodle and owns a pink car. They own a poodle and they own a pink car. It's that spot right there. All right, it's that 250. So they have to own a poodle and a pink car at the same time. So it should be that 250 right there. All right, so it should be 250, and it's over the total. The only time we change the denominator and don't use the total is when you use the word given. So owns a poodle and owns a pink car should be 250 over 20,300. So 250 divided by 20,300. 0.0123, so I'm going to move it over. It's 1.2%, very small. All right, 1.2%. I'm running out of room here, but 1.2% on that. Okay. All right, here's another key word. Look at F. Owns a pink car or owns a poodle. Here's where it's different. The difference between and or. You could own a pink car or you could own a poodle. So I'm only concerned with people who own pink cars or poodles. Well, if I look at all the people that own pink cars, that's that right there. That's 250 and 450. That adds up to 700. But I also care about people who own poodles. Well, that's the 250 and the 1250. I could do this one of two ways. I could add these numbers individually, which would be 1250 plus 250 plus 450, and then divide that by the total, which is 20,300. Or, and this is where people get confused, I could add the totals, 1,500 and 700, but if you add 1,500 and 700, one of these numbers has been counted twice. The numbers that has been counted twice is where they both met. That was that 250 right there. You don't want to double count him. All right, you only want to count him one time. So if you add the 1,500 and the 700, don't forget to subtract out the 250 because you would have double counted him. That term is called mutually exclusive. He can't be double counted. All right, so the way I usually like to do this is just to add these numbers individually. Look at all the people that own poodles. 250, 1250, and then look at all the people that own pink cars. Well, you already counted the 250 because I circled it. So also add the 450. So add those three numbers together. That's what I'm doing right here. And then divide that by the total. So that's going to be 1250 plus 250 plus 450. That's 1,950. I know I'm running out of room here. 1950 divided by the total, which is 20,300. So divide that by 20,300. And it's 0.096, so I'm going to say 9.6% on that one. Okay? Now, if we were in class, I would do the other example, which is pretty much exactly the same, but you're going to see something today on homework, classwork, 5 questions. The questions are all coming from the same graph, but I'm either going to use the word and or given, or I might just say something about how many blue cards are there total or something like that. It'll be pretty simple. But remember, if it's and, it's where the row and column meet. It's that specific cell. If it's or, you're counting the entire row and the entire column, but don't double count where they meet. And if it's given, whatever comes after the word given is your new denominator. All right, so be careful with those. So there'll be 5 questions, opens at 7:45, closes at 7:45 the next morning. And if you got any questions, email me. I think I gave 2 attempts on that. So even if you mess up, you can go back and do it again. All right, good luck.